Okay, welcome back, guys. Session 9. What we're looking at today is sketching quadratics. So we're carrying on with quadratics, and we're going to be sketching quadratics in this session, which does involve, you'll see, solving quadratics is a big feature of sketching quadratics as well. Okay, right, straight in with the lesson, guys. So here we go. Okay, sketching quadratics. Now, a quadratic is always written in this form, as you know. Y equals something x squared plus something x plus a constant. Okay, so that is the quadratic. Now, if a, this number here, is positive, bigger than 0, then the shape of the graph, it will have a U shape. Okay, a U-shaped parabola. Now, if a is negative, so less than 0, it will have a sad face, or an upside down U parabola. Okay, so that's the most important, well, that is a very important thing to start off when we're sketching quadratics. Okay, so we're going to go straight in with an example and what I expect with a sketch. So EG1, sketch y equals x squared minus x minus 6. Showing the points of intersection with axes and the turning point. Okay, so sketch y equals x squared minus x minus 6, showing the points of intersection with the axes and the turning point. Okay, so there's a very clear step-by-step for solving quadratics. So step 1 is determine the shape. Now the shape, okay, well that's a positive 1 in front of the x squared, isn't it? 1x squared. So I know the shape is going to be that way round. That's really important. So that's step 1. Step 2, find the y-intercept. So y-intercept. Now the y-intercept, this occurs if we have a axis here, x, y. The y-intercept, where it crosses the y, this will always be when x is 0. So this is when x equals 0. Now if I put x equals 0 into this equation, I get 0 squared minus 0 minus 6. So y equals that. So the y-intercept is going to be minus 6, okay? So I've got the y-intercept, that's when x equals 0. You can probably predict what my next step will be. Step 3, this is the x-intercept. Now this will usually be 2 intercepts. It's usually going to be 2. Usually 2, but it could be 1 if it just touches. So it could look, so you've got 3 options. It can either look like that, so you've got 2 intercepts. You can either have it so it just touches, and that's called a repeated root. Or the third option is when it's floating and there's no intercept. So there's 3 options there, and we'll see what happens for each. We'll have a look at what happens for those. Okay, so usually 2, and this is when y equals 0. Okay, now when y equals 0, I said, okay, well, 0 equals x squared. What was the equation? Minus x minus 6. Okay, and I'm going to solve this like I normally would. So I'm going to solve this. This factorizes. So x, it's got to times to minus 6, add to minus 1. So minus 3 plus 2, 0. X is going to equal 3 or negative 2. Okay, they're my x-intercepts. So this particular equation has got 2 intercepts. If you solve it and there's no intercepts, or if there's no solutions, then there'll just be no intercepts and it'll float. If there's only 1 intercept, it's going to just touch the x-axis. Okay. Right, step 4, turning point. Okay. Now there's 2 ways of doing it. Well, a few ways of doing this. First way is the complete the square method, which is a pretty useful method. Okay, so if I complete the square, x squared minus I just need to complete the square on the left side. It's a little bit tricky. I'm going to use fractions though. So it's x minus a half squared. It's always half of that. Minus a half squared. Now a half squared is a quarter. And then I've still got minus 6. Okay, so that's what I've done if I complete the square. So I get x minus a half squared minus, so I'm just going to say that's minus 6 and a quarter. Okay. Now the turning point, or the minimum point, is simply whatever the value of the x there, it's the negative sign, so it's going to be a half, and the y coordinate minus 6 quarters. Okay, that is the smallest that could be. That's the turning point. The other option is to use symmetry. So I could use symmetry. Again, is a useful way of looking at this. Now I know the x-intercepts are 3 and minus 2. So the turning point must be the halfway point. Turning point is the midpoint. Okay. So the middle value between 3 and minus 2, I find the midpoint. So if I add those two and divide by 2, I get a half. That is my x. That's my x value for the turning point. To get y, I can just input that back into the equation. So y is going to equal half squared minus a half minus 6. And I end up that is going to be minus 6 a quarter. So I get the same value. So you can either use completing the square, or you can use symmetry once you've worked out the x-intercepts. There is a third option called differentiation, but we're not going to look at that just yet. But these two options always work for quadratics. Okay. Right, I've got all the information needed now, and I can go ahead and sketch this graph. Now, a sketch doesn't have to be accurate in terms of exactly to scale. So I need to draw a nice set of axes, preferably with a ruler. I don't need to start labeling things like that. That's not needed. Now, I know it crosses the x-intercept at 3 and minus 2. So all I'm going to do is here, I'm just going to put 3. I'm going to put minus 2. I'm going to actually put the coordinates in, just to be complete. The y-intercept, if I go back up and check, that was minus 6. I'm then going to put 0 minus 6. It's going to cross through that point. And then I'm also going to put the turning point, which is a half negative. The half is going to be about there. And I'm going to put the turning point. You need to make sure the turning point goes in the right quadrant. And that turning point was a half, negative 6 and a quarter. Now I can go ahead and join the lines with a nice smooth curve. So smooth curve passing through, that's the midpoint. But don't make sure that is the lowest point, because that was the turning point. And then it goes up, and that there would be a good enough sketch. It doesn't need to show any more detail than that. That is absolutely perfect for this example. Okay, that is it in terms of an example. Now just follow the steps. Please do go step 1 shape, step 2 y-intercept, because if it was a negative, you do exactly the same, but when you're joining the points, you join them points, so it's an upside down U shape if the shape was upside down. Y-intercept, x-intercept, turning point. Okay. Right, again, there's another worksheet for you to do on this, guys. I do want you to do all the questions, including the extend on this, because this is a big topic that comes up next year, and it's really, really important that you know how to do it properly. Okay, well done, guys, and tune in for session number 10 coming up shortly.